Okay, we're back again working on that F-150 with the brake pulsation. We got the rotor on the brake lathe. We're going to take a measurement now. We're going to see, they have a minimum machining thickness. If you machine a rotor down too thin, here you lose too much metal. They lose the ability to dissipate heat and they'll warp again, cause noise, and it's a safety limit. The manufacturer sets the safety limit. So I'm going to measure this rotor. I'm going to measure it in numerous spots just to be sure. We're at 33.61 over here. Different spots on the rotor are at 33.76. You can tell the variations in the thickness of the rotor. It's definitely got some warpage. 33.61. So we've got plenty of material to work with. The minimum machine thickness is 32.0 millimeters. So I'm gonna run the lathe bit in on the lathe on the front side. I'm gonna cut the outside. They tend to create a lip on the outside. I'm gonna machine that off real quick. So I'm gonna run the bit in on the rotor. Go about 70% of the way in, and I'm gonna touch it to the surface. Now this is the surface that the brake pad rides on. So we're going to run the bit all the way into the inside edge of the friction surface. We're going to take, there's an edge on the inside, a lip on the inside, which we're going to machine off. So now I'm going to start the bit coming outward on the rotor. And you can already see the variation here. You can see the difference in the depth of the cut. This rotor was definitely warped. If this rotor was completely flat and smooth, that bit, everything would look like the silver part, the newly turned part. You'd have no more of the old surface left. So you can start to see as it's coming out, you can see that going up and down. That should be a true line all the way around the rotor. So we're going to run it all the way out. We're going to see just how bad it looks. And we're going to machine until all of it is uniform. And then we will remeasure to see if we're still within spec.